Hi, accounting class. It's another great day to do some accounting. We're going to look at the homework for chapter 10 here real quick, and we're going to just jump right into it. So we got a $100,000 bond, 5-year bond, 4% coupon, paying semi-annual. So this is the first one with the semi-annual rate, and the market rate is 10%. The number of interest payments here will be the number of years times the amount of times they're paying per year. So it'll be 5 times 2, which equals 10. The cash interest payment will be equal to the face value of the bonds times the coupon rate, divided by, in this case, by 2 because it's semi-annually. Alright, the discount rate is going to be based on the market rate. The market rate is 10%, but we're going to convert it to the market rate per period. The market rate per period is going to be equal to 10 divided by 2, which is 5%. Alright, the present value of the interest payments is going to be equal to the 2,000 times, this is a number we need to look up in the table. I'm not going to go down and scroll down. I think you guys have the skill set now. I'm going to show you what I plug into the table somewhere over here. So we're going to use the annuity table with 10 periods at 5% interest per period. And we'll get this annuity factor from the table, and it will equal to 15,443. There's another sign in here. There's the multiplication sign. Alright, so it's just the amount they're paying every 6 months times the annuity table present value factor that would look up in the table. You'd look it up in the table using the two previous numbers, the 10 and the 5% interest rate. The present value, the face value of the bond is going to be based on the 100,000, and we're also going to use the table, but this time we're not using the annuity table, we're going to use the present value of $1 table. So use the present value of $1 table. We're looking at it for 10 periods. It's the same, same 10 periods and same 5% that we used for the annuity one. But this time we're using the present value of $1. So 100,000 times that factor that we've looked up in a table, you get to 61,391. So we can calculate the present value of the bond equal to 76,834. I'm also going to show you with the calculator real quick how it looks. So we'll turn it on. Apps, Finance, TMB Solver. Number of periods is equal to 10. The interest rate per period is equal to the 5% or the 10 divided by 2. The present value we're going to solve for, so we'll come back to it later. The payment is equal to the 2,000. We'll go ahead and call it the negative. Yeah, it doesn't like when I enter that one. So we'll use the other negative sign. And the future value will pay out 100,000. Now we can alpha solve. And we see the same number, right? 76,834. 76,834. This one would technically round up to the nearest dollar, but that's one of the weaknesses with our table is it does cut off the decimal. It only has 5 decimal places, so don't worry about if it's off by a few dollars. If at the larger numbers we get, the more disparity we're going to see. We're going to see a little bit larger disparity when we're dealing with a $1 million face value in problem number 3. But to me, this ties materially. All right, let's record the journal entries when we issue the bonds. I'm going to think that when we issue them, we're going to collect cash equal to the present value. So that's 76,834. We're going to owe the bonds. Bonds always go on at face, always come off at face. And then the difference here is on the debit side, so we're going to call it a discount. We're also going to call it a discount because we got less cash than the face value of the bonds. 6 months later, we're going to make the first interest payment, so we're going to pay out cash. And we've already calculated the amount of the interest payments, 2,000, add a comma, 2,000. Let's see, we got to amortize this discount. So when we amortize it, notice it's got a debit balance now. We're going to credit the discount to amortize it. And we're going to divide it by the total number of periods. If we go back and look, there's 10 total periods. So this number divided by 10 equals 2,306, whatever, 2317 rounded. Notice we're crediting bonds payable, but notice that relationship, it goes on as a debit. We take it off with a credit. We can add a comma to it. All right, then interest expense would just be our last number that we solved for. In this case, it needs to be the addition of the two, so it would be 4,317. All right, the paying off the bonds. This journal entry is the same no matter what method or you're looking at, no matter what time period or bond you're looking at, because we're already assuming the last interest payment is recorded. So we're going to pay out the $100,000 in cash. We're going to take the bonds payable off our book for $100,000. All right, let's keep moving. Next problem: $100,000 bond, 5-year, 8% coupon. This time annually. All right, and the market rate is 6%. The number of interest payments here will be the 5 years times 1, so 5 times 1 equals 5. I'm going to go and show the one I think of these formulas. Yeah, just to show you. I'm going to show it in the other two as well. I know mathematically you don't need to show it, but I'm going to show it to show the similarities. All right, the cash interest payment will be equal to the face value of the bonds times the coupon rate divided by 1. So we see the formula, it's an even $8,000 cash interest payment they're going to make every year for 5 years. Discount rate will be equal to 6%, and if you want, you can think of it being divided by 1. Again, I know you don't need to divide by 1 or multiply by 1, but I'm just showing it to be consistent with the method. All right, present value of the interest payments. What we're going to do is look it up in the table. The interest payment, they're paying $8,000 every 6 months. So it'll be 8,000 times the present value amount that we get in the table. So we're going to look at the annuity table with 6% in 5 periods. And you get to the present value factor of this number. And if you multiply it, you get to 33,699. We're going to do the same thing with the face value of the bonds. So it's the 100,000 times the present value factor that we'll look up on the table. So if you plug it in the table, we need to plug in the same 6% in the 5 periods. If we plug those in, we get the present value factor of $1 equal to this number, and if we multiply the two together, we get to 74,726. Present value of the bond now will be the addition of the two. All right, the first day of issuance. Oh, I'm going to go and do the calculator real quick. So let's go and do this. Apps, Finance, TMB Solver. Number of periods here is only 5. The interest rate per period is the 6 divided by 1, or 6. The present value we're going to solve for, I'm going to go and set it equal to 0. The payment is going to equal negative 8,000. And the future value is still a negative 100,000 that we're going to pay out. So the present value of this, so if we go to alpha solve, you get to 108,424, and it rounds up to 425, which matches our number that we got with the tables. Let's keep moving. 1/1/2007. I would think about the cash that we're paying out first. We're paying out $8,000 in cash. Oh, no, we're issuing it. Sorry. We're issuing. I skipped ahead in my mind to the interest payment. I'm moving too quick. We're issuing the bonds. So we're going to receive this amount of money as cash. 108,425. We're going to put the bonds on our books for their face value. And the difference will be either a premium or a discount. 825. So we have the premium on bonds payable. This has a normal credit balance, so when we amortize it, we're going to see it being debited down here. Now we'll move on to the first interest payment, and here we'll pay out the cash, what I was talking about, the 8,000. All right, we need to amortize this premium. The premium has a normal credit balance. To amortize it, we're going to need to debit it, and we're going to divide it by the number of payments. So it'll be 8,425 divided by 5. You should get this number, which is 1,000. $685. But that was $8,425 divided by the number of payments, 5. All right, that will be to the premium account. Now the interest expense will be the number that makes it balance, but in this case we need to subtract the two. We're going to debit interest expense. That'll be for the difference of the two, because amortizing a premium reduces the interest expense. All right, the last day is exactly the same. It's going to be exactly the same on all 3 pages. So we pay out the cash of the face value, and we take the bonds off the face value. All right, let's get to the next problem number 3. This time it's $1 million, not $100,000. It's a 7-year, has a 7.5% coupon rate, and it's payable quarterly or 4 times a year. And the market rate of interest is 12%. All right, the number of interest payments will be equal to 7 years times 4 payments a year. 7 times 4 is 28. Cash interest payment will be the face value, the $1 million, times the coupon rate of 7.5% divided by 4. The discount rate will be equal to the 12% divided by 4, which equals 3%. The present value of the interest payments, it's going to be this amount, and we're going to look at the amount into the annuity table. In the annuity table, you're going to use the 28 and the 3%. So the 28, 3%, you should get to this number. If you multiply these, every payment they're making every quarter by that present value factor for the annuity, you get to 351,827. Now we're going to do the same thing for the face value, so it'll be the $1 million face value. We're going to plug it into the present value of $1 table, and we'll get this factor, 0.43708, and it's equal to 437,080. Now the present value of the bond, if we add the two numbers together, whoops, I need to go back. We get to that number. Let's go and check it with our calculator. So the number of periods is equal to 28. The interest rate is equal to 12 divided by, ooh, I made a mistake, didn't I? 12 divided by 4 equals 3. Alright, 3%. Present value we'll solve for. The payment is going to be equal to a negative 18,750. The future value is going to be equal to a negative $1 million. We can alpha solve for the present value, and we get to 788,903. Again, we see like a $4 difference here, a $3 or $4 difference. That's because the tables only keep 5 decimal places, and a calculator is more precise. So we'll view the calculator answer as more correct. But I'm going to go ahead and show the journal entries as if this was a number. All right, the present value. All right, we're going to issue the bonds. We're going to collect the cash equal to the present value. We're going to have bonds on our books for the face value. The difference is going to be on the debit side, so it's going to be a discount on bonds payable. On the first interest payment, we're going to pay out cash equal to the amount we're paying out every quarter. Which is 18,750. Let's see, we need to amortize this discount. We're going to divide this discount by the total number of periods, which is 28. So 211,093 divided by 28 should equal, oh yes, on the credit side, right? This one's a debit, so we need to amortize that on the credit side. And then our offset, what makes it balance, will be our interest expense. In this case, it will be the summation of the two. Alright, the last date is exactly the same. Alright, I know I flew through it, but I will upload this document on Blackboard as well, so you guys can see it in more detail and look through it. But let me know if you guys have any questions, and I'll see you guys next time. Alright, bye-bye.